Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, today we're gonna solve another question paper, another recent question paper of Excel. So let's get started. So let's at first let us read this question. The question says, uh, cold water fish required a minimum of 8 parts per million by mass ppm of oxygen dissolved in water. Okay, the minimum mass of oxygen required in 1 kilogram of water is this. Okay, so these are the options given. So in here they have asked us to find the minimum mass of oxygen required in 1 kilogram of water. Okay, so the information here is given that this is the information that is given, that is the ppm is given. Okay, now we need to find the minimum mass of oxygen. Okay, so here we will use this formula. Simply we're gonna use this formula in order to find the mass of solute, which is uh, oxygen. So basically ppm by mass, parts per million. In other words, parts per million by mass means mass of solute divided by mass of water, mass of solute divided by mass of solvent multiplied by 10 to the power 6. This is the general formula. So we're gonna use this in order to find the minimum mass of oxygen. So let's see. So in here, value for ppm is 8. Let us just substitute the values. Okay. So in here, mass of solute, we don't know the mass of solute. This should be the mass of oxygen. Okay. Let us just leave it like that. Mass of water, we know the mass of water is 1 kilogram. Well, here is one thing that we need to know, that here all the answers are in gram. So we need to convert this kilogram into gram. So we know that 1 kilogram, from ordinary level we already know that this is 1000 g gram. So we can convert this into this. So 1, therefore 1 kilogram is equals to 10 to the power 3 grams. As simple as that. So let us write the mass of water here. So the mass of water will be 10 to the power 3 gram. Since all the answers are in gram, so we need to convert this into gram. Okay, so we need to convert kilograms into gram. Okay, so it is really important, otherwise your answer might come wrong. Okay, your answer might be wrong. So if you don't convert this into gram, so be careful about that. And we just simply do the math, do the calculation. So if we make mass of oxygen as subject, then we will get something like this. uh, 8 into 10 to the power minus 3 gram. So I know fellas that most of the answer might come as uh, A, because most of the student made a mistake over here. So that is why the answer of the answer might come as A. That's because they didn't convert this kilogram into gram. Okay. I also faced this problem while solving this problem. I have forget to convert this kilogram into gram. So that is why my answer initially has come into A. The answer was A. Okay. So this is totally wrong. Okay. So we need to convert this kilogram into gram. Okay. So in order to find the answer. So as you can see that most of the student might fall into this loophole. So this is the loophole that the examiner has kept. So in order to avoid this loophole, we need to convert this kilogram into gram. As simple as that. And we need to do all this calculation into gram. Then it would be perfect. Okay. So therefore the answer would be B. Okay, so B is the correct answer. So B would be the correct answer, not A. No, 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 fellas. B is the answer. Okay, B is the correct answer. So in here, there are some important things that we should recall. Here we should recall 1 kilogram is equals to 10 to the power 3 gram. This is as simple as that. And another thing that we need to recall that we need to convert uh, kilogram into gram. That's it. That's it for number one. That's it for question number one. Okay. So I hope that you have overcome this problem. Overcome this problem uh, by this meantime. So now let us move on to the next question. Okay. So I hope that you have understood the previous question as well as the previous solution. So if you have any problem, if you still have any problem, please let me know in the comment section. Okay. So I'm always there to help you out. So now let us move on to the next question. So here, calculate the total number of atoms in this amount of this molecule. Okay. So here the molar mass is given. Oh, fine. This makes things much more easier. Here the Avogadro's constant is also given. Oh, thanks a lot, examiner. Okay. So here this makes the thing much more easier. So here we need to be careful about one thing, that they have asked us to find the total number of atoms, not molecules. Okay. So for that we need to be careful about this keyword. So this is the keyword for this question. So most of the student might fall into this trap. Okay. So better be careful. Okay. We better be careful. So here uh, we just use this formula and everything would be fine. Total number of atoms. Total number of atoms is equals to uh, number of moles multiplied by Avogadro's constant, which is Avogadro's constant. Okay. So here we're gonna use this formula simply. So let us at first find the number of moles. So it is very easier to find the number of moles. So here we need to find the number of moles for C2 dichloro uh, methane. Okay. So let us at first find number of moles of CH2 Cl2. Okay. So here we're gonna find the number of moles. Here, since the molar mass is given and mass is given, so it will be much more easier for us to find. So here the mass is given as 8.5. Here the molar mass is 85 gram per mole, and we're gonna find the number of moles as, let me do the math, 8 sorry 8.5 divided by 85, right? So here the number of moles come as 0.1 mole. Okay, so we have find out the number of moles. Uh, oh, we have made a one mistake over here in this general formula. Okay, so let me rewrite this down once again. So the total number of atoms would be uh, number of moles, okay, multiplied by Avogadro's constant, and total number of atoms. Okay, so total number of atoms, as simple as that. Since they have asked us to find the total number of atoms, so we need to multiply number of moles. Besides multiplying with number of moles with Avogadro's constant, we need to multiply this whole thing with total number of atoms present, since they are talking about atoms. Okay. So if we just do this thing only, then we're gonna find molecules. So up to this is the formula for molecule. So if we multiply this two things, then we're gonna get number of molecules, total number of molecules. And if we multiply this total number of molecules with total number of atoms, then we're gonna find actual atoms, okay, present in this compound. So as simple as that. So here, in order to find the total number of atoms, we're gonna multiply. We're gonna use this formula. We're gonna use this formula: number of moles multiplied by Avogadro's constant multiplied by total number of atoms. Okay. So here, the number of moles that we have find out earlier is 0.1 mole multiplied by Avogadro's constant, which is given here. In this case, 6 into 10 to the power 23. 6 into 10 to the power 23. Okay, and the total number of atoms here is, let us count here, uh, two, 1 carbon, 3, then 5. So 5 number of atoms. So 5 atoms are present. So we are not talking about molecules. We are talking about atoms. So let's just multiply it. So if we multiply, then we're gonna get something like this. Uh, 3 into 10 to the power 23. Okay, so the answer would be 3 into 10 to the power 23, which is atoms. So this is how we're gonna find the total number of atoms by using this general formula. So here the things gets much more easier. So if we use this formula, so since we have 1 mark for this question, okay, since this is MCQ, since this is multiple choice question, so we gonna get 1 mark per question. Okay, so here we have valuable time. We're gonna have some valuable time over here. We're gonna have very little time, uh, 1 minute per mark. So we're gonna get for this for solving this question, we're gonna get 1 mark. Okay, so one minute. So in order to answer this question, we're gonna get total time 1 minute for this particular question. So time is really important, and we always gonna try our level best in order to solve this question in with between this time. Okay, we're not gonna take much time in to solve this question. Okay, not more than 1 minute. Okay, so here the answer would be 3 into 10 to the power 23 atoms, which is C. Okay, so I hope that fellas you have understood how to solve this question. So here the basic thing was we just need to multiply these two things with total number of atoms, then we're gonna get this value. So most of the student might get another value, which is 6 into 10 to the power 22. So here in here the total number of molecules, uh, sorry, total number of molecules, total number of molecules were 6 into 10 to the power, sorry, let me do this elaborately, then the things would get much clear. Okay, so here the total number of molecules would be number of moles, which is 0.1 multiplied by Avogadro's constant, which is 6 into 10 to the power 20. So this would give us the total number of molecules, which is 6 into 10 to the power 23. Okay, so this is the total number of molecules present in this compound. Okay, sorry, 6 into 10 to the power 23. I was wrong, sorry. So here this is the total number of molecules present. So in order to find the total number of atoms, in this question they have asked us to find the total number of atoms. So we just need to multiply this with 5, since there are 5 atoms present, okay, in this molecule. So total number of therefore total number of